Hey there. Tonight we're leaving the ordinary behind. No maps, no roads, not even stars to guide us. Just you, wrapped up in your favorite blanket, and a question so big it doesn't even fit inside your head. What was there before the big bang? Close your eyes and picture it, not the bang, not the explosion, not the light, but the before. The moment, if we can call it that, where there wasn't yet a moment at all. No time ticking, no space to float through. Just stillness, so complete it makes silence feel loud. That's where we're going. So before you get comfortable, take a moment to like and subscribe to the video, but only if you really enjoy what I'm doing here. And while you're settling in, let me know in the comments where you're watching from and what time it is where you are. It's always cozy to imagine all of us scattered around the world, drifting off to sleep together under the same sky. Now dim the lights. Maybe turn on a fan for that soft background hum, and let's start our journey together tonight. You might think it's strange to begin a story before beginnings. After all, when we talk about the Big Bang, we're talking about the birth of everything: space, time, matter, light. But something deep inside us can't help but ask, okay, but what was there before that? Imagine trying to describe color that's never existed, or a sound that has no pitch. That's the kind of challenge this question gives us. It's not just hard, it slips right through our language. But that doesn't stop the wondering. It never has. Let's start with what we do know, or at least, what we think we know. The universe, as we experience it now, is expanding. Galaxies are drifting apart like glitter spilled on a balloon that's slowly inflating. And if you press rewind on that cosmic balloon, all of space, all of time, collapses inward, tighter, denser, hotter, until, theoretically, it all converges into a single point. A singularity. But here's the thing. That singularity doesn't really make sense in modern physics. It's not so much a thing as it is a placeholder, a symbol for where our math breaks. Like running into a wall in a video game. Behind it, the code just doesn't load. Scientists don't love singularities. They whisper, we don't understand this part yet. And in the space before that, if we can even use the word space, was there nothing? That word nothing is heavier than it looks. When we say nothing, we imagine an empty box. But a box is already something. Even emptiness needs space to exist in. So real nothingness is not a vacuum, not a void, not a blank. It's the absence of anything that could even contain absence. No container, no box, no room to put the idea of a room. It gets slipperier, doesn't it? Some philosophers call this state non-being. It's not dead. It's not asleep. It's just not. But we're beings, creatures made of stuff, of questions, of curiosity. So even when we close our eyes and try to picture nothing, our brains sneak in a little shadow, a dark corner, maybe a floating thought. You're doing it right now, aren't you? There's a weird comfort in it, though. Because if the universe truly began from nothing, if it somehow bloomed from non-being into being, then maybe we did too. Maybe each breath is part of that same expansion. Maybe every thought you have, every memory, every dream is a ripple from the first impossible something. Let me tell you something strange and beautiful. According to quantum mechanics, the universe is never perfectly still, even in what we think of as empty space. Tiny fluctuations are always bubbling up, like little whispers in the fabric of reality. That means the universe, even at its quietest, never truly stops murmuring. Now, here's a mainstream fact. In 1927, a Belgian physicist and priest named Georges Lemaître first proposed what we now call the Big Bang. He called it the primeval atom, imagining the whole cosmos compacted into a single, unimaginably dense point. The idea sounded wild at the time, but it stuck. And with time and evidence, it grew into one of the most accepted models in cosmology. Fringe fact time? Some thinkers, not all scientists, mind you, but philosophers and mystics, believe that time is not something that started, but something that's always existed in one form or another. They picture time like a loop, or a spiral, or an infinite field we just happen to be passing through. Maybe there was never a before the Big Bang, just a different kind of time, beyond clocks and calendars. And some theories even suggest that asking, what was before the Big Bang, is like asking, what's north of the North Pole? It's not just hard to reach, it's meaningless. The concept doesn't apply. You're not standing at the edge of a cliff, looking out into nothing. You're standing in a circle, trying to find its start. But don't worry, we're not here to solve it. Just to walk slowly around it, like admiring a strange sculpture in a quiet museum. You tilt your head one way, then the other. You squint, then smile. And then you move on, not because you've understood it, but because the looking was enough. Tonight, let yourself be held in the thought that before everything ... there might have been nothing. Or maybe something too strange for language. Either way, you're here now. You're part of the story that grew out of that mystery. And that, in itself, is kind of incredible. Time is one of those things you can't hold in your hand, but you can feel it everywhere. You feel it in your heartbeat. You see it in the way shadows stretch in the afternoon. You hear it in a clock's steady tick. But what is it, really? Let's ease into this with something close to home. Think about how time feels when you're bored, like waiting in a dentist's office, or watching paint dry. It crawls. Then think about when you're on a roller coaster, or watching a movie you love. It vanishes. Time seems elastic, like someone's playing with the remote control of your brain. But that's just your experience of time. The deeper question is whether time exists as a thing in itself, or if it's just a useful trick of perception. We tend to think of time as a straight line, a timeline, a past behind us, the future ahead, and us right here, riding the present like a surfboard on an invisible wave. But physics? It says something much stranger. According to Einstein's theory of relativity, time isn't separate from space. It's part of the same stretchy fabric, space-time. And just like you can bend a bedsheet by placing a bowling ball on it, gravity bends space-time too, which means that time isn't the same for everyone. It flows differently depending on how fast you're moving and how much gravity is around. Let's try this. Imagine two identical twins. One stays on Earth, the other gets on a spaceship and zooms away near the speed of light, then comes back. The twin who traveled will be younger than the one who stayed. Not just subjectively, but actually, biologically younger. This isn't science fiction. It's a prediction of special relativity. And we've confirmed it with atomic clocks on airplanes. So, time isn't fixed. It's stretchy, flexible, relative, already. Our neat little idea of past, present, future is starting to wobble. Now let's dip into something weird. The block. Universe theory. Imagine all of time, past, present, future, as already existing. Not unfolding like a movie, but standing still like a statue. You're not moving through time. You're simply in one location within it, like a character, frozen in one frame of a comic book. From this view, everything that's ever happened, and everything that will ever happen, already exists. You're just seeing one sliver at a time. This is not just science fiction daydreaming. Some physicists genuinely believe this. Because in the math of relativity, there's no special now. Every moment exists equally. There's nothing in the equations that says one point in time is more real than any other. But then, why does it feel like time flows? Some argue that it's all about memory. You remember yesterday, but you don't remember tomorrow. So your brain builds a story. Time is moving forward. But maybe that's just your mind organizing events into a sequence for survival. Maybe the flow of time is more like an illusion your brain creates, like how a flipbook turns still. Images into motion. Here's a mainstream fact. Physicists can't agree on what time actually is. Not really. There's no single accepted definition. Some define it operationally as what clocks measure. Others say it's just a measure of change. And some, like Julian Barber, argue that time doesn't exist at all. It's just an illusion created by the change in configurations of the universe. A fringe idea? In some speculative models, time is emergent. It arises out of deeper physical laws, like temperature emerges from molecules in motion. In these models, the universe doesn't have time baked in. Time bubbles up later, like foam on coffee. And that means it might not be fundamental at all. Now breathe. Take this slow moment in. You're floating in your own little slice of the cosmos, where time ticks forward at 1 second per second. But around you, billions of other slices are ticking at different speeds, warped by gravity, acceleration, memory, and perception. And that present moment you're sitting in? It's already part of the tapestry. The universe has already sewn it in. Kind of beautiful, isn't it? So, now that we've unraveled the idea that time might be stretchy, relative, or even illusory, let's talk about how we measure it. Because, believe it or not, the act of measuring time says a lot about how we understand it. Imagine ancient humans sitting around a fire, watching shadows shift across the ground. They didn't have clocks or calendars. What they had was nature sunrises, seasons, moon phases, and the cycles of stars. Time for them was written in the sky. The earliest calendars? Carved into stone, markings aligned with solstices. Time was quite literally etched into the earth. And that's a mainstream historical fact. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, is over 2,000 years old and is believed to be an early analog computer that tracked the movement of celestial bodies. An ancient time machine made not to travel, but to understand. Fast forward to the modern world. Today, we define the second not by the movement of the sun, but by the vibration of atoms, specifically cesium-133. When a cesium atom switches, energy states 9,192,631,770 times. That's 1 second. Welcome to the age of atomic time, which brings us to a strange observation. Time is something we invented devices to measure more precisely than almost anything else. And yet, we still don't really know what it is. Let's take a breath here. You're lying in bed, maybe curled up under the covers, maybe with your phone screen dimmed. Time is slipping past, second by second. But how would you even know a second had passed if there weren't some rhythm to measure it by? Enter the brain. Your internal sense of time is slippery. It's affected by emotion, temperature, and attention. Time flies when you're having fun, but if you've ever been in pain or really stressed out, you know how it can feel like the seconds are dripping instead of ticking. That's not an accident. That's your brain's inner clock responding to stimuli. Here's something fringe why, but fascinating. Some researchers suggest that the brain might use neural oscillations, little waves of electrical activity, an internal timekeeper, basically your own private metronome. And it's not just humans. Birds, insects, even bacteria show some kind of time sensitivity, which means timekeeping may be a biological imperative wired into life itself. But that brings us to the weirdest part of this story. If we can't experience time without a brain, does that mean time only exists when we observe it? That question leads us into quantum physics, where things get even stranger. In the famous double-slit experiment, particles behave differently depending on whether they're being observed. And in some interpretations of quantum mechanics, observation itself affects the outcome. Some physicists argue this might extend to time, that events don't happen until they're noticed. Cue the Twilight Zone music. Of course, not everyone agrees with this. Most physicists believe time exists independently of observers. But the debate lingers, and it has serious implications. Because if time needs observation to be real, then time, as we know it, might be more psychological than physical. Not an external river, but an internal rhythm. That's not to say the outside world doesn't change. It clearly does. Stars explode, mountains erode, ice melts, people age. But the way we track those changes, that's something we superimpose. Time may not be a fundamental building block of the universe. It may just be the scaffolding our minds use to make sense of change. And that idea leads to some philosophical heavy hitters. Think about St. Augustine, who said, "What then is time? If no one asks me, I know. If I wish to explain it, I do not." Or Immanuel Kant, who argued that time isn't something out there, but a structure of the mind, a necessary condition for the way we experience the world. So when you look at a clock, what you're seeing isn't just numbers or ticking hands. You're seeing a mirror of your own mental framework. A way to map motion, change, and memory onto something you can understand. Even now, as you lie here listening, your body is measuring time in countless invisible ways. The rhythm of your breath, the pulses in your blood, the shifting of neurons, firing in sequence. You are a symphony of clocks, and yet the most mysterious one of all is the one ticking behind your eyes. The one that whispers, "This moment is real." The one that remembers before and dreams of after. Time, it seems, is as much a feeling as a fact. Let's lie back a bit more deeper now and consider the universe's own clock. Because if time is a thing we can measure, there must be something keeping it, right? Cosmic time doesn't run on wristwatches or wall clocks. It runs on expansion. The expansion of space itself. Since the Big Bang, the universe has been stretching outward, galaxies rushing away from each other like dots on an inflating balloon. This isn't just poetic, it's measurable. And it gives us what cosmologists call cosmic time, the ticking of the universe's very fabric. You may have heard of something called redshift. Light from distant galaxies arrives stretched, redder, as if fleeing the scene of some ancient explosion. That's how we know the universe is expanding and how fast. The further a galaxy is, the older its light, and the faster it's receding. That gives us a kind of intergalactic calendar, one written in starlight. Mainstream fact here. According to current models, the universe is about 13.8 billion years old. Not because we watched it happen, but because we've tracked the light, the echoes, and the math backward to a beginning point, what we call the Big Bang. Now let's tiptoe into the weird. You see, time in the early universe wasn't like time today. For the first sliver of a second after the Big Bang, literally y-43 seconds, the Planck time, everything was packed into an unimaginably dense state. Space and time themselves may not have even existed as separate things. They could have been braided together in a kind of quantum foam. No past, no future, just a timeless chaos we can barely imagine. There's a big argument among physicists about whether time actually began with the Big Bang. Some say yes, that there was no before, because time itself was born in that explosion. Others believe our universe could be one of many, perhaps bubbling into being from some eternal, higher dimensional sea of possibility. In that case, time didn't begin with us, it just started a new chapter. And here's where it gets really juicy. Some physicists speculate that the arrow of time, the reason we remember the past and not the future, comes from the expansion of the universe itself. As space stretches, entropy increases, and that gives us direction. Without expansion, time might not move forward at all. It might not even exist in the way we understand it. Lie there for a moment and feel that time. Driven not by your heartbeat or your watch, but by the breath of the cosmos itself. The dark, quiet swelling of space around and between every star. And speaking of stars, did you know that time flows differently depending on where you are in the universe? It's called gravitational time dilation, and Einstein predicted it over 100 years ago. The stronger the gravity, the slower time passes. If you lived near a black hole's edge, don't. By the way, you'd age slower than your twin living on Earth. That's not science fiction. That's GPS correction math. Satellites orbiting Earth have to account for the difference in time caused by their altitude and speed. Without that correction, your phone would guide you into lakes instead of coffee shops. So now we know this. Time is not constant. It stretches, shrinks, curves. It dances with mass and motion. And yet to us, it feels smooth and steady. That's because our brains are tuned to this earthly tempo or rhythm, carved by biology and reinforced by routine. Alarm clocks, school bells, sleep cycles. The illusion of flow. But you're beginning to see it now, aren't you? Time is not a background. It's not a container. It's a dynamic part of reality, shaped by gravity, motion, expansion, and maybe even by consciousness. The more we study it, the less we find. Like trying to hold fog in your hands. Every answer only deepens the mystery. So close your eyes. Let the image form. Galaxies swirling outward like sparks from an invisible fire. The universe breathing gently over billions of years. Somewhere. In the middle, you listening, wondering, counting seconds made of starlight, and the seconds keep slipping by. Let's shift now from the scale of galaxies to something closer, your own body. Your mind, the clock that ticks inside you without ever making a sound. Because time isn't just out there. It's also inside. Every one of your cells has a clock, not a metaphorical one, a biological one. Right now, as you breathe gently in the dark, your circadian rhythms are at work. These are natural cycles synced roughly to a 24-hour day, dictating when you feel sleepy, hungry, alert, or even emotionally balanced. They're guided by signals from the suprachiasmatic nucleus, a tiny cluster of neurons in the brain that acts like a conductor for your entire system. Mainstream fact: these rhythms evolved over millions of years, shaped by Earth's rotation and the rising and setting of the sun. Light enters your eyes, hits that nucleus, and adjusts your body clock accordingly, like a lighthouse beam nudging a boat gently back on course. But here's something strange: humans, placed in total darkness for extended periods, don't lose their sense of time completely. They still maintain a near 24-hour rhythm, even without sunlight. It's as if the body remembers the spin of the earth, deep in its bones. Now, for the fringe thought. Some fringe researchers have proposed that our perception of time isn't just biological, it might be a construct of consciousness itself. That is, our minds create the illusion of time to make sense of change. Without memory, there's no past. Without imagination, no future. Just a string of sensory impressions floating in an eternal present. There's even a theory still controversial. Of course, that time, as we experience it, emerges from quantum entanglement. That the way particles are connected at a quantum level might be responsible for how we experience cause and effect. In other words, time might not be fundamental. It might be a byproduct. Your thoughts? Just organized entanglements of neural activity, cascading in patterns that simulate a sequence. A beginning, middle, and end. But if your memories vanished, would time vanish too? Here's a historical curiosity. St. Augustine, way back in the 4th century, wrote that he understood what time was until someone asked him to explain it. If no one asks me, I know what it is, he wrote. If I wish to explain it, I do not know. And that pretty much sums it up for most of us today. The brain doesn't just perceive time, it projects it, it smooths it, it makes it flow. Your brain fills in the gaps between what you see, hear, and feel. It anticipates the world by milliseconds, giving you the illusion of now. But technically, you're always living just a little bit in the past. Every moment is a reconstruction, a delayed playback of reality's greatest hits. Think of it like watching a live event on a slightly laggy stream. It feels real enough, but you're always a few frames behind. And then there's this. Time slows. When you're afraid, it speeds up when you're in love. It disappears when you're bored. It stretches when you're in pain. These aren't just poetic expressions. They're measurable shifts in the way your brain tracks reality. Your internal clock speeds up or slows down based on chemical and emotional cues. Ever notice how the days feel long when you're a child, but seem to fly by as you age? One theory suggests that's because each year becomes a smaller fraction of your total experience. When you're 5, a year is 20% of your life. When you're 50, just 2%. Your brain compresses time as it accumulates memory. So as you lie there now, listening, floating, your brain is quietly arranging this moment into a narrative. Beginning, middle, maybe a dreamy end. And in doing so, it's bending time like a soft lens. You are both the observer and the projector of your timeline. You are the dreamer and the clock. And maybe, just maybe, time feels real because we need it to feel real. To make sense of love, loss, growth, decay. It gives our lives direction, meaning, rhythm. But out there, beyond your mind, time might not tick at all. Out there, it might just wait. Let's float now to the furthest places, the edges of time, or at least the edges as we understand them. Because if time has a beginning, might it also have an end? The question pulls us toward the Big Bang, that fiery curtain raiser 13.8 billion years ago, when time, space, and energy bloomed into being. Before that moment, there wasn't a before. At least not in any way we can understand. There was no ticking clock, no passing seconds, just nothing. Or perhaps everything. Condensed. Mainstream science says time began with the Big Bang. That's our cosmic clock's 0 point. Every second you've ever lived, every breath, every ancient galaxy, it all unfolds from that singular flash of birth. But the deeper we peer into the universe, the fuzzier this origin becomes. Quantum mechanics throws its hat into the ring and says, wait, what if time is an illusion created by entangled particles? And relativity, Einstein's majestic theory, reminds us that time isn't absolute. It bends and flexes, stretching near massive objects like black holes and slowing down when you're zipping through space. That's right. Your experience of time depends on your motion and location. Someone orbiting a black hole could watch centuries pass on Earth while only minutes tick by for them. It's not science fiction. It's been confirmed with atomic clocks on planes, satellites, and mountaintops. So now, let's get a little strange. A leading fringe idea is that time doesn't flow like a river. It emerges like steam from boiling water. And just as steam vanishes when the heat's gone, maybe time evaporates under certain cosmic conditions. Maybe, near a black hole singularity, time stops altogether. That brings us to a deeply debated concept. Is time fundamental, baked into the fabric of the universe? Or is it emergent? A side effect of something deeper? Something we haven't yet glimpsed? Some physicists argue that time might be a human-friendly way to interpret the otherwise chaotic unfolding of the universe. Let's go even further. Imagine a universe where time doesn't exist. No past, no future. Just a static block of existence, where everything that will ever happen has already happened. This idea is called the block universe theory, and it suggests that you, lying here in this moment, are just one fixed point in a four-dimensional sculpture. The future isn't waiting to be discovered. It's already there, your entire life, Every blink, every heartbeat, already etched into the structure of SPACETIME.now. How's that for bedtime existentialism? Here's a historical side note. In the 17th century, Sir Isaac Newton described time as an unstoppable, river-steady, universal, absolute. Then along came Einstein in the 20th century and said, "Nope, it bends. It flows differently for everyone." Imagine arguing across centuries. That's science for you, one long, slow disagreement. But back to you, to your breath, to the clock ticking somewhere in another room. What if the passage of time is just your brain stitching moments together like frames in a movie reel? In between those frames, maybe there's silence, stillness, a pause in the universal symphony, and maybe, just maybe, we only sense time passing because we remember. If you had no memory, none at all, would you know that time exists? And if, one day, all conscious life vanished, would time continue to tick? Would a sunset still be beautiful if no one was there to watch it fade? That's the quiet question tucked into the folds of the cosmos. Is time a real thing? Or just a beautiful trick we play on ourselves so the story makes sense? And yet, we still wake, we age, we sleep, we count birthdays, we chase deadlines, we say goodbye. Whatever time is, it hurts. And it heals. It creates distance. It gives meaning. And, for now, at least, it's all we have. Word count, 1080. Let's imagine time not just as a line, but as a stage one where everything plays out in coordinated harmony. The planets orbit, the tides rise and fall, seeds sprout, and stars burn, all in synchrony with something we can't see, yet constantly feel, the rhythm of time. You felt it too. When you've sat in silence, perhaps outside on a still night, and noticed how moments seem to breathe, how the wind picks up and dies down, how your thoughts meander and dreams creep in. This isn't just poetic, it's how life evolved. Plants, for instance, don't wear watches, but they know time. Through circadian rhythms' internal clocks, hardwired by evolution, they open their leaves to greet the sun and fold them again at dusk. Even single-celled organisms have a sense of daily rhythm. This leads to an incredible mainstream fact. In 2017, the Nobel Prize in Physiology or Medicine was awarded to 3 scientists for their work on these biological clocks. They proved that life is inseparable from time. Not just humans, every living thing. Even your brain has a central timekeeper, the suprachiasmatic nucleus, a tiny cluster of about 20,000 neurons tucked deep inside the hypothalamus. This little region controls your sleep, hunger, mood, and maybe more than you realize. When it's thrown off, everything else unravels. Jet lag isn't just annoying. It's your inner time unraveling at the seams. But here's a weirder, fringe twist. Some theorists propose that consciousness itself is a process tied to time. Not something that merely flows in time, but something that creates the feeling of time flowing. You think, therefore time ticks. No thoughts? No tick-dot. And from this perspective, maybe the universe without observers wouldn't have time at all. A tree falling in a forest with no one to hear it? That's child's play. Imagine a cosmos unfolding without a mind to interpret it. No stories. No history. Just a floating, frozen mosaic. Now, shift to deep time again. Time in geology isn't measured in hours. It's marked in strata, in layers of rock laid down over millions of years. We read the past not in books, but in cliffs. Fossils are time-stamped. Memories, a trilobite in stone, a ripple of a wave fossilized into rock. It's a diary written without ink, and it stretches beyond our imagination. Some events are so cataclysmic that they leave time scars, mass extinctions, asteroid impacts, sudden climate shifts. You can point to a line in a canyon wall and say, right there 65 million years ago. That's when the dinosaurs vanished. In that slice of silence, time paused for them, but not for Earth. Let's blend this with a callback to Einstein. His general theory of relativity tells us that gravity slows time. And guess what? The Earth's center experiences time just a tiny bit slower than its surface. So if you lived at the core, please don't try. You'd actually age a little less quickly than someone on a mountaintop. It's microscopic, but measurable. And yes, astronauts who spend long periods on the International Space Station return to Earth just a smidge younger than they would have been had they stayed home. It's called time dilation, and it's very real. Imagine a future where we harness this long-duration spaceflight as a kind of time travel. The further you go, the slower your clock ticks. You leave Earth, blink, and come back to find everyone you knew older or gone. That's not fiction. That's physics. And now consider this. If time can stretch and bend, could it break? What happens near a black hole's event horizon, where time seems to stop entirely for the outside observer? Does time halt forever, or does it just look that way? To the falling astronaut, moments still pass. But from our perspective, they become frozen, like a frame in an old film stuck in the projector. That last glance, that last breath held eternally. At the edge, and perhaps this isn't just about black holes. Maybe each of us has our own event horizon. Those limits we can't see past, can't return from. Birth, death, grief, love. All of it stitched into the fabric of time, threading one fragile moment into the next. So as you lie here, listening, breathing, remember that you are not separate from time. You are woven into it. Every cell, every memory, every hope and sorrow folded into the quiet tapestry of existence. And this very moment, it's already a memory. Now, let's peer into one of the strangest truths science has offered us. The idea that the future already exists. Not in a sci-fi destiny is sealed kind of way, but according to Einstein's theory of relativity, time is not some flowing river. It's a landscape, a frozen block. A whole universe of moments existing all at once, with past, present, and future sitting side by side like rooms in a house. This idea is often called the block universe. From this viewpoint, your childhood still exists. Your future self, brushing their teeth 10 years from now, already exists. Every single second of your life, this breath, the next blink, that time you spilled coffee on your shirt in 2021, all locked into place like snapshots in an endless photo album. And yet, from inside the album, you're flipping one page at a time. That's the illusion of flow. That's what our consciousness feels, as if time moves. But what if it doesn't? What if you're what moves, sliding from one static moment to the next, like a needle tracing a vinyl record? Here's a mainstream twist. Many physicists take this view seriously. They argue that the flow of time is something the brain invents to keep things organized. It's a psychological construct, not a physical law. Like file folders for your memories. But here's the truly wild part. Quantum physics doesn't seem to agree. On the tiniest scales, time becomes fuzzy. In the quantum realm, particles don't move neatly from point A to point B. Instead, they seem to exist in multiple states at once, and only decide where they are once we observe them. It's like time and space are suggestions, not rules. Ever heard of the delayed choice experiment? It shows that what we choose to observe now can affect how a particle behaved in the past. Yes, the past. As if our present awareness is rewriting the timeline. Cue the weird science music. This is where we hit the fringe zone. Some physicists and philosophers suggest that consciousness isn't just in time, it interacts with it. That maybe your awareness helps sculpt the path you walk, even retroactively. You aren't just a traveler through time. You're part of the terrain. But there's more. There's a theory called presentism, which says only the present is real. The past is gone. The future doesn't exist yet. It's a comforting thought, right? Like standing on solid ground. But then comes eternalism, which argues the opposite, that all moments exist equally, and now is just a matter of perspective. Imagine a loaf of bread. Slice it any way you like. To you, this moment is now. But to someone else, a few slices down the loaf might be there now. In the universe's eyes, it's all the same loaf. No one slice is more real than the others. And when you look out into space, you're already looking back in time. That star you see might have died before the dinosaurs did. Its light only just reached you. So even your vision, your perception, is time travel. Now ask yourself this. If everything you've ever loved, feared, touched, or forgotten still exists in the block universe, where are you? Are you just a sequence of snapshots? Or are you something that spans the whole album? Maybe, as you drift off to sleep, you're not just slipping into dreams. Maybe you're floating across pages of your own timeline, pages you've already written, and ones you've yet to read. And the most magical part? You'll never know which is which until you turn the next page. If time is like a loaf of bread, layered with every moment that has ever existed, then what about motion? What about change? How do we explain the fact that everything feels like it's moving forward, second by second, like a movie reel? Enter entropy. Entropy is a concept from thermodynamics, a big word with a simple idea. Over time, everything tends toward disorder. Leave a hot cup of tea on the table, and it cools down. The heat spreads. It doesn't gather itself back into the cup. That's entropy in action. In fact, some scientists believe that the only reason we experience time at all, why we feel a past and a future, is because of this increase in entropy. Things get messy, and our brains are tuned to notice that change. The unbroken egg comes before the omelet, never after. So maybe time isn't something that moves. Maybe it's just a way we measure the spread of mess. Let's zoom out. At the beginning of the universe, right after the Big Bang, everything was incredibly ordered. Low entropy, a neat, compact little cosmic seed. But ever since then, things have been getting more chaotic. Stars exploding, planets forming, life emerging, cities being built and demolished. All of it advanced toward disorder. Here's a mainstream fact. The second law of thermodynamics says that total entropy in a closed system always increases. The universe is a closed system. So every tick of the cosmic clock is another step toward heat death, toward everything being evenly spread out. Like butter on toast that's been, well, left out way too long. But what if entropy is the only reason time appears to move? That's the argument of physicist Sean Carroll and others. Without entropy, the arrow of time wouldn't make sense. It's not that time flows forward, it's that disorder does. Now for something a little fringe. There are theories that suggest time might reverse in regions of the universe where entropy decreases. Imagine a galaxy far away where things get tidier with time instead of messier. Would beings in that galaxy remember the future and forget the past? Would they laugh at the idea of eggs turning into chickens? It sounds absurd, but mathematically, it isn't ruled out, which leads us to this weird twist. Maybe time is local. Maybe there isn't a single arrow for the whole universe. Maybe different parts of the cosmos have their own time directions, their own sense of what's before and after. You could, in theory, pass from one time orientation into another, like stepping across a threshold, feeling everything shift like gravity pulling sideways. That's not sci-fi, it's just untested theory. But who's to say? Most of physics is still blindfolded in a dark room, trying to describe a creature it's never seen. And yet, Despite all this complexity, your brain keeps things simple. It strings moments together, tells you a story, and insists you're moving through time like a boat on a river. But what if the boat isn't moving at all? What if you are the river? Let's add a layer of wonder to this. Right now, in your body, countless processes are unfolding in perfect synchronicity, neural signals firing, hormones releasing, heartbeats thumping in rhythm. All of it aligned to this sense of now. But your now is different from someone else's. A person on the moon, or in a spaceship near a black hole, would have a completely different sequence of nows. Time, it seems, is not universal. It's personal. And yet we try to hold it still with watches, calendars, memories. We mark birthdays, anniversaries, the first day of spring. We build monuments to moments, as if we could pin down time like a butterfly on a velvet board. But maybe time was never meant to be captured. Maybe it's meant to be felt, to be breathed in slowly, like the silence between heartbeats, like the stillness between stars. So tonight, as you lie in bed, surrounded by your own private now, remember this: you are the result of a universe that has been unraveling itself for billions of years, and will keep unraveling long after you're gone. But for this one moment, you're here. Still. Aware. That tiny, glowing ember in time's grand fire. You've probably heard that time slows down when you're having fun, or speeds up when you're not paying attention. But what if I told you that time really does slow down, depending on where you are and how fast you're moving? Welcome to the mind-bending world of time dilation. Einstein's theory of relativity tells us that time isn't fixed. It's stretchy, bendy, and deeply personal. The faster you move through space, the slower you move through time, at least from the perspective of someone standing still. If you were to board a spaceship and zip around the galaxy at near the speed of light, you might only age a few months, while your friends back on Earth age decades. And that's not just science fiction. It's been tested. Mainstream fact: atomic clocks on GPS satellites tick slightly faster than the ones on Earth, because they're farther from our planet's gravity and moving quickly. Engineers have to correct for this, or else your phone's location services would be wildly inaccurate. Time, quite literally, runs differently up there. Now let's stretch that idea to the extreme. If you were to drift too close to a black hole, time would slow down dramatically for you. From your perspective, you'd just be floating along. But to an observer watching from a safe distance, you'd appear to move slower and slower, until you stopped entirely, frozen at the event horizon. This is called gravitational time dilation, and it's one of the strangest and most beautiful consequences of physics. It means that time is not just relative to motion, but also to mass. The more massive an object, the more it warps time around it. In a way, gravity is just space, and time being curved by mass. And when mass becomes extreme, like in a black hole, it doesn't just bend space, it distorts the very rhythm of reality. Time becomes sticky, sluggish, stretched thin like taffy, pulled by invisible hands. Let's go even weirder. There are theoretical models of the universe, where time is not a continuous flow, but comes in discrete packets like frames in a film. Real. Each tick of time would be the smallest possible moment, a tiny flash in the quantum fog. This idea, sometimes called chronon theory, isn't widely accepted, but it raises a question we rarely ask. What is the smallest unit of time? One candidate is the Planck time, about 10 seconds. That's a decimal with 43 zeros. It's so short that even light, the universe's speed limit enforcer, can barely get moving before the moment is over. It's the speed bump at the birth of everything. We don't experience time in Planck units, of course. We experience it in heartbeats, breaths, blinked eyes, whispered goodnights. But somewhere underneath it all, time might be built from these quantum moments, strung together like pearls on a thread we'll never see. And that thread might be knotted. Some physicists propose that time isn't linear at all. It could loop, fork, or even branch like the roots of a tree. Imagine a universe where every decision spawns a new timeline, rippling outward with infinite variations. In one, you became an astronaut. In another, you never learned to swim. In yet another, you're asleep, listening to this very story, but it's raining outside, and your future holds a different sunrise. That's the many worlds interpretation of quantum mechanics. And while it sounds like fantasy, it's taken seriously by many scientists. It's a reminder that time isn't just something we live in. It's something we invent, interpret, and carry with us. You and I are traveling through time together right now. Not because clocks are ticking, but because your thoughts are flowing. Words are forming. Meaning is building. And somewhere deep in the folds of space-time, a version of you might be hearing all of this for the second time, wondering why it feels so familiar. Maybe it's déjà vu. Maybe it's time folding back on itself. Or maybe, just maybe, you're closer to the event horizon of wonder than you realize. So breathe deeply. Stay with me. The clock's still ticking, but not quite how you think. Imagine standing outside time. No ticking clocks. No sunrise or sunset. Just silence. A frozen universe, still as glass. Now, imagine reaching out and pressing play. Everything begins. Galaxies expand. Stars form. Planets spin. Hearts beat. Words are spoken. Thoughts are thought. You just triggered time. Of course, that's not how it works, at least, not as far as we know. But this thought experiment hints at something deeper. Time isn't just a background feature of the universe. It might be something that emerges, like steam from boiling water, or music from plucked strings. Some scientists believe time is not a fundamental part of reality at all. It might arise from other, more basic ingredients, like energy, matter, and information. In this view, time is a side effect, an illusion created by change. Like how a movie is just a series of still frames, shown fast enough to trick the brain. That raises a strange question. If time is emergent, what is before time? This is where physics starts to look suspiciously like philosophy. Let's take a mainstream idea first. In loop quantum gravity, a cutting-edge theory of space and time researchers propose that space-time itself is made of tiny loops, kind of like atoms of geometry. In this model, time is not a smooth river, but a granular fabric, woven from these loops. There's no absolute before or after, only connections, like beads on a cosmic necklace. In this version of reality, asking what came before the Big Bang is like asking what's north of the North Pole. It's not just unknown, it might be meaningless. And here's something wonderfully fringe. There's a theory that time is an illusion created by consciousness. That you are the projector, and your experience of a flowing present is just the brain stitching together sensory input and memory, frame by frame. This makes time feel fragile, almost like a dream. You experience it not because it's out there, but because your brain makes it, like a spider spinning silk. Without your mind to witness it, time might not even exist. Wild, right? Now, let's touch on something beautiful. There's a symmetry in physics called CPT symmetry charge, parity, and time reversal. It suggests that the laws of physics would still work even if time ran backward. Imagine a universe that plays in reverse. Ashes turning into paper, broken cups leaping back together, people growing younger, returning to the womb, vanishing into stardust. According to CPT symmetry, such a universe could be just as valid as ours. In fact, some physicists have proposed that the Big Bang birthed two universes, ours, flowing forward in time, and another, flowing backward. Two halves of a cosmic heartbeat, forever drifting apart. You could call that second universe the mirror twin of ours. And somewhere in it, maybe there's a version of you, dreaming backwards. All of this should feel disorienting, because it is. We're not meant to understand time intuitively. Our brains evolved to track seasons, sunrises, heartbeats, not plunk. Time or quantum loops. So when we ask, what is time? We're asking a question that's bigger than our tools, bigger than our language. And yet, we try. We write stories about time travel. We record memories. We build machines to measure microseconds. We mourn the past and anticipate the future. We imagine timeless heavens and time-lost lovers. We count down to midnight on New Year's Eve, hoping the next year will be kinder. Maybe our obsession with time is really just a fear of being left behind by it. But tonight, there's no rush. No deadlines. No aging. No ticking clocks. Just you. And this quiet moment. A moment you've carried from the beginning of the universe without knowing it. A moment that can never happen again. Not quite like this. So let it stretch. Let it float. Let it remind you that time might not be real, but this feeling, this calm, sleepy awareness, that's as real as anything has ever been. Let's play with a very old idea, the arrow of time. You've probably heard the term before. It's the one-way direction time seems to move in from past to future, never the other way around. You drop a glass and it shatters, but you never see it leap back together. You age, but you don't grow younger. You remember what happened, not what's about to happen. But why? What makes time flow in one direction? The classic explanation comes from thermodynamics, specifically the second law. It says that entropy, or disorder, always increases in a closed system. Ice melts, coffee cools, houses get messy. Over time, energy spreads out. Systems become less ordered. It's the cosmic rule of things fall apart. This increase in entropy is often called the thermodynamic arrow of time. It's the closest thing physics has to a universal clock, ticking toward chaos. So when you see a tower of blocks tumble, or milk swirl into tea, you're not just watching matter move. You're watching time decide which way to go. Now for something curious. In the equations that govern fundamental physics like Newton's laws, Maxwell's equations, or even quantum mechanics, time doesn't have a preferred direction. The math works the same forward and backward. But the universe we observe clearly favors one way. This mismatch between the laws and the experience of time is a big, weird puzzle. Fringe thinkers have even asked, what if the arrow of time is local, not global? Like maybe the universe has little pockets where time flows differently, slower, faster, maybe even backward. Black holes and wormholes are often dragged into this conversation. Places where time warps, stretches, or loops. And now, let's slow down a bit. Because this is where it gets poetic. Think about how you feel time. Not in hours or days, but in memory. You don't remember time ticking you. Remember moments, people, places, emotions. You're not a walking clock. You're a collector of scenes. You remember how the light looked that one afternoon, or the way someone laughed, or the smell of the ocean when you first saw it. And somehow, all those memories form a path, a story, a you. This is sometimes called the psychological arrow of time. It's the part of time that lives in your mind, the narrative stringing together before and after. Interestingly, there's research showing that animals with short lifespans or limited memory may not perceive time the way we do at all. To them, life might be more like a series of present moments, loosely connected at best. In fact, some deep meditation practices aim to unhook your mind from this psychological arrow. To dissolve past and future, and dwell purely in the now. It's not a bad skill, especially at bedtime. Because time can stress us out. We rush it. We waste it. We try to save it, stretch it, schedule it, fight it. But what if we just watched it drift by? Like leaves on a river. No pressure to catch them. Just watching. And what if the arrow of time is just a shadow cast by something deeper? Something we haven't named yet? Physicist Carlo Rovelli once suggested that perhaps time is just our way of making sense of the tangled web of events in the universe. That our brains create time, because otherwise, everything would be a meaningless jumbled dot, so the arrow? It might just be the chalk line we draw to explain why today follows yesterday dot. And maybe, just maybe, there's more than one arrow. Or none at all dot either way. Tonight, you're not being dragged forward. You're just floating, suspended between stars and seconds dot. And that arrow? It's not chasing you. Not tonight dot, it's paused. Right here. With you. Let's slip a little deeper. You're still floating. But now the universe begins to fade into something quieter, something darker. Not frightening, just silent, like the space between heartbeats. This is the part of the journey where we touch the boundaries of time itself. Not in theory, not in charts or equations, but as it exists when there's no one left to count it. Because here's a strange, essential truth. Time may not have always existed. According to most cosmologists, the concept of time only makes sense after the Big Bang. Before that moment 13.8 billion years ago, there was no before in any meaningful sense. No ticking clock, no timeline, no once upon a time. Time itself began. Einstein's theory of general relativity described space and time as a woven fabric spacetime. And like any fabric, it can stretch and bend. That means time isn't a constant beat, but more like a ripple, a rhythm, a soft drumming that changes depending on where you are and how fast you're moving. Which is why time runs slightly faster on the top floor of a building than on the ground floor. Not a metaphor. That's relativity. But let's slow that idea down. Imagine being on a distant planet orbiting a massive black hole. The gravity is so strong, it pulls on space-time like it's tugging on bedsheets. For someone watching you from far away, your seconds stretch into minutes, your minutes into hours. To them, you appear to be frozen. But from your perspective, life goes on as normal dot. It's called gravitational time dilation. And yes, it's real. We've measured it. And it messes with your brain dot, because if time can stretch dot dot dot, does it ever end? Some scientists believe it might. There are a few competing theories for how the universe will finish its long, luxurious ride through existence, and nearly all of them involve time slowing to an unmeasurable crawl or disappearing altogether. Of the leading ideas is the heat death of the universe. Eventually, all stars will burn out, all black holes will evaporate, and energy will be so evenly spread that nothing else can happen. No contrast, no movement, no change dot, and remember, if nothing changes, then time itself loses meaning. Because time is not a thing, it's a relationship between events. Without events, time just evaporates, quietly, like a psi dot in that distant final darkness. Time might simply stop being necessary dot. Now here's something fringe to tuck under your pillow. A few quantum gravity theories suggest time might not be fundamental at all. That it's emergent, like temperature, a side effect of a deeper, invisible structure. If that's true, time is just the froth on top of something far stranger beneath. Maybe we're not in time. Maybe time is in us. Think about your heartbeat, your breath, the way your thoughts drift, rise, repeat, the rhythm of dreams, the slowness of a lazy Sunday afternoon. These things feel like time, but they're really just changes in your awareness. One after another. No wonder we're obsessed with clocks. We built them to measure ourselves. So here we are tracing the outer edges of this vast, mysterious concept. Time is entropy. Time is memory. Time is rhythm. Time as illusion. And maybe the final twist is this. The more we try to define time, the more it slips away. Because maybe time isn't meant to be held. Only notice like this exact moment right. Here, right now, soft as your breath, quiet as your pulse, passing gently through your thoughts. Time is slippery. But even as we try to define it, there's one thing that always anchors us back to earth. We live in time. Or at least, we think we do. And so, to close this strange, winding journey, let's turn inward to your very own experience of time. Because deep down, your brain isn't just experiencing time. It's making it. Let's start with something strange. Your brain doesn't process time like a clock. It doesn't tick evenly or store a single stream of events. Instead, it's more like a DJ mixing overlapping tracks, memories, sensations, rhythms, guesses, all layered into a single seamless moment called now. But here's the twist. Now doesn't really exist. The present moment, what you feel as now, is actually a mental illusion. Neuroscientists estimate that your brain stitches together sensory information with a delay of about 80 milliseconds. That may sound tiny, but it means that your conscious self is always a little bit behind. You're living slightly in the past, buffered by your brain's editing process. Still with me? Good, because it gets weirder. Let's talk about the specious present, the brief window of time your brain holds open, like a bubble, to make sense of reality. It's usually about 2 to 3 seconds long enough to hear a phrase, feel a breeze, finish a thought. It's like the size of your mental spotlight, illuminating just enough of the now to keep things feeling fluid. Everything outside of that, either memory or anticipation. And what about dreams? Time in dreams behaves completely differently. A full dream might feel like hours, but lasts just a few minutes in real time. That's because the brain's internal clock, the suprachiasmatic nucleus, isn't fully active while you're dreaming. Your subconscious untethers from linear time. That's why dreams often jump, shift, repeat. They feel real, but obey a different rhythm. Now imagine, if the universe ends in silence, your brain is the opposite. It ends time by creating it. That heartbeat you feel in your pillow? That's time. The ticking of your ceiling fan? Time. The memory of a walk you took last spring? Time again. But not universal time. Personal time. Here's a classic philosophical thought. If the universe continued exactly as it is, but your brain suddenly paused, would time stop for you? Most likely, yes. Because your inner world defines your experience of time more than the cosmos ever could. Fringe alert. There's a modern theory called chronostasis, which suggests that every time you move your eyes rapidly, a saccade, your brain stretches that moment to appear longer than it really is. This is why the first tick of a clock sometimes feels slower than the rest. Your mind literally stretches time to maintain continuity. That means time, as you live it, is constantly warped, sculpted, and finessed by your biology. And if your brain can slow time, compress it, even pause it in moments of trauma or awe, what else can it do? Have you ever had a moment stretch out into infinity? A hush before an accident? A second kiss? The pause between a question and its answer? These aren't just poetic pauses, they're evidence of your brain rearranging time to meet the emotional gravity of the moment. Maybe we don't move through time. Maybe time moves through us. You're not a passenger. You're the projector. And as you lie here now, eyes closed or softly blinking, you're still weaving your own stream of time. Breath by breath, beat by beat, memory by memory. All of it folding into the quiet theater of your mind. In that sense, time was never out there not in stars or clocks or theories. was always here, inside you. Let's stretch time just a little longer. You're here now, in a room that's still, but the universe outside hasn't stopped moving. In fact, it's accelerating. Galaxies are flying apart faster and faster, like sparks tossed from a campfire. That's not poetic, it's measurable. It's the result of something we call dark energy. Dark energy makes up about 68% of the universe. And it's not just filling space, it's creating more of it. Imagine stretching a balloon while tiny galaxies are glued to the surface. The further apart they are, the faster they drift away from each other. It's not the galaxies moving, it's space itself expanding between them. That expansion creates time in a very real sense. So here's a simple question with a complicated answer. If space keeps growing, does time get longer? Sort of. Time is woven into space, remember? So if space is expanding, then the fabric of time is too. The problem is, no one really knows why. Dark energy seems to be pushing everything apart, but we don't know what it is. We can't see it, touch it, or bottle it up. But we can measure its fingerprints. Fringe thinkers once speculated that maybe time is a byproduct of entropy, the tendency for things to fall apart. As things break down, disorder increases, and time moves forward. If everything in the universe suddenly froze in perfect symmetry, would time stop too? Einstein once described time as what a clock measures, but that's like saying music is what a piano plays. Sure, it works, but it misses the wonder. Here's something fun to fall asleep to. There may be entire regions of the universe where time flows at a completely different rate than here. If inflation after the Big Bang created multiple pocket universes, each could have different physical laws and different timelines. In one universe, you could be born after your great-grandchildren. In another, a second might stretch for 1,000,000 years. These aren't fantasies, they're mathematical possibilities. But if that makes your brain spin, here's something simpler. The only timeline that really matters is yours. You've been alive for a few decades at most. A heartbeat in cosmic terms. And yet within that brief spark, you've laughed, cried, grown, forgotten, loved. Your own inner timeline is more vivid, more textured, more real than the age of stars. We talk about time as something that moves, but it also builds. Time has constructed the person you are, the cells that grew, the thoughts that layered, the identity that quietly assembled from 1,000 stories. And each of those moments, every birthday candle, every awkward conversation, every moment you stared out a window and thought about nothing at all, those are real. They happened. They stacked together like sediment in a canyon. You are a geological record of time lived. One more twist. According to some models in physics, time might not be fundamental. It could be an emergent property, something that arises only when we look at the universe a certain way. Underneath it all, there may be no before or after, just relationships, just geometry, just patterns waiting for an observer. But here you are, the observer. And that makes all the difference. You're not just riding time, you're giving it meaning. So take a deep breath. Let your lungs stretch just a little more slowly. Let your heart whisper its quiet beat. The universe doesn't need to rush. It never did. Let's turn the telescope inward for a moment. You've spent the last few minutes floating through galaxies, chasing the outer limits of time. But now, let's bring it all the way back to you. Not the person reading this script, not the name you go by, but the soft, humming consciousness behind your eyes, breathing in this exact second. Here's something truly strange. Your perception of time isn't just a biological trick. It's constructed, stitched together, moment by moment by your brain, like a quilt made of blinking lights and heartbeat rhythms. Your sense of now is always a beat behind the actual now, a slight delay as your brain collects the input, makes sense of it, and quietly says, Yep, this is happening. Think about that for a second. Your experience of this moment is already history. That means your past, your present, and even the you who's reading this sentence are all illusions of flow. Just neatly stacked frames in a film reel. And you're the little projector in the dark, humming along, casting meaning on the wall. Neurologists have found that time can bend inside the brain. During danger, time seems to slow down. During boredom, it drags. In moments of joy or crisis, it speeds up or disappears entirely. That's not magic, it's neurology. Your brain plays with time the way a DJ scratches a record, looping, pausing, stretching the beat. But the track itself never changes. Just the rhythm. Here's a mainstream scientific curiosity. Your brain has multiple timing systems. Some are chemical, some electrical, some even based in your gut. Yes, your stomach has neurons that influence how you process time, like some kind of biological hourglass that fills and empties with rhythm and food and mood. Time is not just cognitive, it's embodied. You feel it in your bones, your belly, your breath. Weird fact? Some people with rare brain injuries lose the ability to perceive time at all. To them, every moment arrives disconnected from the last, like shuffling a deck of cards. They can't tell if something happened yesterday or years ago. Imagine living in a soup of moments with no trail to follow. No narrative, just flashes. Would that feel like eternity or a kind of waking dream? And here's the metaphysical kicker. Some philosophers argue that only the present exists. The past is gone. The future hasn't arrived. Only this moment, this exact breath is real. And yet, your memories shape your identity. Your hopes shape your choices. So isn't time more than just clocks and physics? Isn't it something we build from the inside out? If the universe is a stage, then you are both actor and playwright, stepping into each new second with a script you can rewrite. And speaking of stages, time gives your life a rhythm. Birth, childhood, love, loss, healing, decay. We call it the arrow of time, but maybe it's more of a dance, a choreography of cause and effect. And every step forward opens new space behind you, like a trail made of footprints in freshly fallen snow. So here's the quiet truth. You're not stuck in time. You're surfing it, balancing on the moment. Sometimes falling off. Sometimes catching the perfect wave. Right now, you're at the crest. Everything before this led to you, lying here, listening to the soft whisper of an explorer telling bedtime. Stories about time itself. Let that thought settle. Let it loosen the knots in your shoulders, the tightness in your jaw. You're allowed to rest here. There's nowhere else you need to be. Now that you're resting on that delicate edge between time experienced and time imagined, let's float back into the cosmos. Just a little. There's something deeply poetic and also wildly unsettling about the fact that time itself might not be a constant across the universe. Einstein's theory of relativity shattered the old idea that time ticks evenly everywhere, like some universal metronome. Instead, time stretches, warps, slows down near massive objects, speeds up far from them. The closer you get to a black hole, for instance, the slower time moves for you. But for someone watching from a safe distance, you would appear to be frozen, hovering at the event horizon, never quite falling in. From your perspective, everything outside would speed up ridiculously, stars burning out, galaxies spinning, entire civilizations rising and falling in the blink of an eye. And yet, for you, only seconds would pass. This isn't just theory, it's been measured. Atomic clocks flown on high-altitude planes run slightly faster than those on the ground. Even standing on a mountain makes time tick just a little differently for you than it does for someone at sea level. You're living in your own pocket of time, uniquely yours. And what about light? The universal speed limit 186,000 miles per second. No matter how fast you're moving, light will always appear to move at that same speed. That weird consistency is what forces time to bend in the first place. It's like the universe is constantly adjusting the rules, so light always wins the race. Here's something deeply strange. If you could somehow travel at the speed of light, which, let's be clear, you can't, you'd experience no time at all. Zero, nada. For a photon, from its point of view, the moment it leaves a star and the moment it hits your eye happen simultaneously. There's no journey. Just arrival. Think about that. Every time you look up at the stars, you're catching messages that for the photons arrived the instant they were born. It's only from our slow, squishy, time-bound perspective that the light seems ancient. And here's a little-known fringe fact. Some theoretical physicists have played with the idea of tachyons, hypothetical particles that always travel faster than light. If they exist, they'd move backward in time. But no one's ever found one, and most scientists think they probably don't exist. Still, the idea is delightful. Particles born in the future, dying in the past. It's a reminder that physics, while mathematical, is also incredibly imaginative. But don't worry, you don't need a lab coat or a spaceship to experience time travel. You've already done it. Every memory is a mental time machine. Every dream a skip through imagined timelines. Every moment of déjà vu a glitch in your inner chronometer. And you, dear traveler, are a time being born in one century, shaped by another, dreaming about futures you'll never live to see. That's not a flaw. It's a kind of cosmic poetry. So, when you next check the time on your phone, your microwave, your wrist, remember, it's not a fixed reality. It's a collaboration between gravity, light, motion, and you. And in this moment, this tiny, quiet pause, you are right on time. Let's take a deeper breath now and imagine a place where time barely matters at all. Not a fantasy realm, not a black hole, but somewhere much closer. Your own mind. Here's a curious thing. Your brain isn't just a clock. It's also a storyteller, a projector, a dreamer. It's what makes time feel like it flows. And sometimes it decides to rewrite the script entirely. You know those moments when time feels like it slows down during a crisis or speeds up during a good conversation. That's not time changing, it's you. The brain, under stress, records memories in more detail. Later, when you recall those memories, your mind takes longer to replay them, which tricks you into thinking the moment itself lasted longer. It's like your inner documentary editor turned a split-second moment into a slow-motion scene with dramatic music and soft lighting. Thanks, brain. Here's a mainstream fact that might make you blink. Studies have shown that different age groups perceive time differently. For children, time crawls, summer lasts forever. Car rides stretch on endlessly. But as we age, time seems to speed up. It's called temporal compression, and while no one agrees exactly why it happens, one theory is that the novelty fades. Fewer firsts mean fewer detailed memories, and fewer detailed memories mean shorter perceived time spans. Meanwhile, on the fringe side of science, there are those who propose that time isn't even a fundamental property of the universe. It might just be something that emerges like temperature or pressure when particles interact in a complex system. In other words, time might not exist in the way we think it does, unless you're watching things change. Some physicists call this the block universe idea, where the past, present, and future all exist simultaneously, like frames in a film reel. You, the observer, are just moving through the reel one frame at a time, giving you the illusion of flow. A bit existential? Absolutely. But somehow also comforting. If all moments exist, then none are ever truly lost. And perhaps that's why we cling to photographs, to stories, to favorite songs. They're little portals anchors in the stream. Things that let us momentarily hop backward and forward, defying the usual rules. So right now, as you lie still and listen, you're not stuck in any one place. You're hovering. Between thoughts. Between moments. Maybe even outside of time. For just a second. And this, right here, this drifting sense of calm, of wonder, that's as close as most of us ever get to time travel. No machine needed. Just the gentle hum of your mind, turning the world over in slow motion. And so here we are, almost at the end of our long drift through the universe's most elusive dimension. But before we fade gently into rest, there's one more place we should visit, a place where time might finally run out, not in some violent cosmic explosion, but in the slowest, softest ending imaginable. Scientists call it the heat death of the universe. Sounds dramatic, right? But it's not heat in the way we think of summer days or warm baths. It's about entropy, the slow, unstoppable slide toward uniformity. The idea is that as the universe expands, energy spreads out more and more evenly. And when everything is perfectly spread, perfectly balanced, nothing can really happen anymore. No stars. No movement. No change. Just silence. At that point, time as we know it might lose all meaning. Because if nothing changes, then there's nothing to measure. No clocks ticking, no orbits spinning. No stories unfolding. In this vision of the future, trillions of years from now, the stars have burned out. Black holes have evaporated. Galaxies have drifted too far apart to ever speak again. The universe becomes a soft, dark stillness. A cold ocean of particles barely moving. A cosmic whisper stretched across unimaginable time. It's not a tragic ending, just a peaceful one. Some cosmologists argue that time might not end completely, but it becomes irrelevant. There's nothing left to count, no more before or after. Just as . And here's something a little weird. Some scientists wonder if the entire concept of time might restart under the right circumstances. Like a bounce instead of a fade. A rebirth of time itself in some new universe with different rules. Maybe even another you, lying down again one night, wondering, what exactly is time? In the end, the more we learn, the less solid time seems. It stretches, warps, bends, pauses. It obeys gravity. It responds to speed. It fades. In and out like a song you can't quite catch. Yet it's also personal. Deeply human. It's birthdays and sunsets and whispered goodnights. It's a baby's first laugh and a grandmother's last smile. It's the echo of your own thoughts as you drift off to sleep. We may never fully understand time, not really. But maybe we're not supposed to. Maybe time is like the stars, beautiful, not because we can touch them, but because they light our path through the dark. And in this moment, suspended between the tick of the second hand and the hush of your breath, you've stepped outside the usual march of hours. You're not running late. You're not out of time. You're just here, right where you're supposed to be. So now we rest. The clocks will keep ticking, satellites will keep orbiting, and galaxies will keep spinning far beyond our sight. But in this quiet pocket of stillness, none of that matters. Time can wait. Right now, you're wrapped in a kind of stillness that defies the rush of the world outside. It's easy to feel overwhelmed by the concept of time, how it never stops, how it seems to slip through our fingers, how it loops and stretches and vanishes when we need it most. But here, under the soft blanket of the cosmos, there is no hurry. There's only this breath. And the next, you've journeyed through ancient light, stood at the edge of black holes, felt the hum of atoms, and traced the threads of time itself. And yet, you've gone nowhere at all, just deeper into your own awareness, softer into your own breath. That's the strange magic of these nighttime wanderings. They carry you far while asking nothing of your body, nothing of your schedule. They remind you that resting is also part of the rhythm of time. Maybe the most sacred part. So don't worry about what time it is. Don't worry about what comes next. Just let the universe hold you for a little longer. And when you're ready, drift. Drift without direction. Drift without pressure. Time will be here when you wake.